today. I am not coming at you live from a camping trip. I'm actually having internet problems today, so I had to come over to a friend's house and sit in a pop-up camper on a very wintry spring day. So it'll be really fun to be able to do all of this from a pop-up camper. Really shows our capabilities of virtual working. So I'm Hot Dog Hilary, otherwise known as Hilary Petticord. And Beth, if you want to just say hello.
Sure, yeah, I'm Beth Russell, also known as Blizzard Beth. And yeah, Hilary and I, both snow lovers, and excited to be chatting with you today about SOS Explorer.
Yeah, absolutely. We work at the NOAA Global Systems Laboratory, Advanced Technology Division. We also both work for CERES, which is a cooperative institute for research in environmental sciences at CU Boulder. And if you're just joining us, please go ahead and download SOS Explorer onto your phone or tablet right now. That way we can get the full experience here. So by the way, when you get SOS Explorer app downloaded onto your phone, which hopefully it'll download pretty quickly, please chat to us in the chat where and what you teach.
So we wanted to give you a little bit of background on what SOS Explorer is, which this whole session revolves around. It's possible that you've heard of Scienceonosphere there in the upper left-hand corner. It's a roughly 6-foot animated globe that we've installed in almost 180 science museums around the world. There are a handful of schools that have been able to install them in their facilities, but it's a little out of reach price-wise for most schools. But we know that it's a great education tool, and there's a huge data catalog that comes along with it that we really wanted to find out how to get that into the hands of teachers and students outside of just the museum setting. So what we did next was create what we call SOS Explorer. It's a flat screen version. In the middle picture there, you can see that's an installation of it at CU Boulder. And we've set it up as an exhibit. So again, science museums, some schools, you could have a touchscreen kiosk with it and they can explore the app and see all different kinds of things. It's a piece of desktop software that we sell to sites. And that got us a long way to getting into more classrooms and in front of more students. But still, price was an issue for a lot of folks, and just a technical challenge of having the right computer and getting everything set up. So our final step that we have taken is now making the app that hopefully you all are downloading right now, which we also named SOS Explorer. It's pretty much the same thing as the desktop version with a few features that aren't quite the same, but the experience is very similar. And so there's about 130 data sets that are available through this app. It's a great way to explore the data that traditionally was just available on the 6-foot globe, but now you can have it right there on your phone, and it's a free app. So anyone can have it, the teacher can have it. If you allow your students to have devices, they can all download it as well. So we are going to show you a little bit about how we think you can use SOS Explorer for your classroom and for data literacy.
Yeah, absolutely. So just quickly, I wanted to mention, let's see, I'll turn my video off over here. Why do we believe that data visualization in education is important? So first of all, I know that you deal with data in your classroom, and data in numbers is difficult to interpret. So it's really important to collect and put into these very nice tables But it can be challenging to work with the amount of data that we're working with in our data visualization. Now, graphing data is wildly important, especially if the students are graphing the data, and they can certainly make a lot of inferences and understand patterns, a couple of patterns at once when you're graphing data. And we do still imagine that that's useful in the classroom. However, you can really only show a couple trends, and it's not really the level of sort of the aha and the excitement that you can get from data visualizations. So with the same data that you just saw in the table and the graph, we have in a full animation showing carbon dioxide concentrations around the globe between 2000 and 2015. And I like to say an SOS data set is worth 1,000 graphs. And so we're just gonna quickly pop over and show you what it looks like. So this is what you should be seeing, more or less. There are a few minor differences between my desktop version and the version that you are playing with on your phone or mobile device. But essentially, when you open it up, this is what you see. You see there are a number of real-time things that we have here. So for example, these clouds, we can kind of see some clouds moving and probably swirling across the United States today. We can also see, if you look pretty closely, there's this Sirigay, I think is the name of this typhoon that is wreaking havoc over the Philippines right now. So all of that is real time. Also real time is the day-night terminator. So we can see that we're in complete daylight, whereas on the other side of the planet right now, it is dark. We also have topography shading as well as bathymetry shading in the ocean. And so that's kind of the first thing that you see when you open it. So there's a lot to see there and a lot of different data sets all kind of smashed together. You'll also notice that when you touch the globe, you're going to get the latitude and longitude at the bottom of the screen. So that's kind of helpful when you're trying to tell students where to look for things. So we have, to get started in some fun things, we have the data set window, which you open up with the green arrow. We can sort it by choosing different categories. I'm gonna go ahead and click right here on CarbonTracker, this CarbonTracker fixed scale, because that's the data set that we were just talking about in the slides. So just to be aware that this particular application that you are working with on your phone or device is a streaming app. Therefore, it will load a certain resolution, but then increase resolution depending on your internet connectivity. So we kind of went over the data set window a little bit and the fact that the data sets are alphabetized. And now we're looking at CarbonTracker. So one thing I wanted you to notice is that all the things on the screen, because the screen real estate is obviously a really important feature of an application, you're able to move or close at pretty much anything that pops up on the screen, whether that be a text box or a color bar or a more info video, for example. And speaking of more info buttons, on the right here, basically we've added, because we cannot be there to give a presentation to you and your students like we do on the sphere, we really want to be able to add some supplemental information so that you can find out some things on your own. So if you press on the first button at the top on the upper right up here, you'll see a YouTube video, which I'm going to start playing here. And now to get us warmed up and interactive, get everyone talking, I guess, writing, typing. Let's go ahead and start a Jamboard. So Beth is going to share a Jamboard in the chat, and I'm going to pull that up here. How would you describe what you see in this pump handle 2014 history of atmospheric carbon dioxide? There is a lot there, so I'm just kind of asking you to describe it.
And if you're not familiar with Jamboards, you can add sticky notes. So the fourth button down, click that. It's a sticky note. You can type in whatever you want and then stick it onto the page.
So I'm going to switch over to the Jamboard, and there's the YouTube link, just in case you were unable to get that pump handle graph. Awesome. So obviously these are ways that we ask students to look at things, you know, take their time, slow down. What are the trends? What are the observations that they can make? So I don't know exactly how many of you, but I appreciate your participation. So I'm gonna head back over to SOS Explorer and close that box. And by the way, at the end of that animation, which you can obviously use anytime in your classroom, just look up carbon pump handle graph. It shows actually the carbon dioxide throughout history from ice cores in Antarctica as well as Greenland, I believe, Vostok and Sipol, yeah. So you can really notice the variation over time and also those patterns. All right. So back to the way that we can use this tool. So I would say, by the way, with respect to CarbonTracker, I think it's a really fabulous data set, and there's a bunch of tools that work really well with it. So whether you're an earth science, life science, or biology, physical science teacher, honestly, the annual and long-term carbon cycle is a really neat thing. And you may want to try analyzing this one. So play around with transecting this one as well, so that you can watch carbon dioxide concentrations change depending on the latitude that you're looking at here. So that's a really fun one to play with as well. And we're going to go over some more analysis here in a second. So the buttons on the bottom right, I just wanted to mention as well. You perhaps have already figured all these out, but you can change to a two-dimensional view. Obviously, it's really nice on a flat screen to be able to see the two-dimensional view and to have the option to do either. We also have overlays, so we're going to play a little bit with having the option to help out with your geographical knowledge there as well. And then the tools here, we have analyze for a few particular data sets that we have data. We have measure. I'm trying to remember if you guys have draw on yours. And then the feedback button is here. So if you are doing something really cool, or you found a bug, or you just want to tell us that you're impressed with our creation, we would love your feedback. That also provides your email in case we have some updates and things like that we can share with you. I'm just going to pause here. Beth, do you see any questions, or does anybody have any questions so far?
I think I've answered all our questions so far in chat. So I think we're in good shape, but if there are any questions people want to ask, please do.
Awesome. All right. We're going to go to our first Mentimeter question then. So please find the Aurora data set.
Oh, Hilary, can you jump back for just a second? How did you draw the bisect line on a smartphone?
Yes. So on a smartphone, I believe, is exactly, hopefully, the same way it looks on here. So if we're in CarbonTracker, which is an excellent one to bisect down the Atlantic Ocean, for example, you go to Tools, Analyze, and then there are 3 buttons here. So this is the probe. So you can kind of probe around for the values. And then the transect, essentially, you would just use your finger and just draw all the way down as far as you can. And if that doesn't work for you, please let us know. Okay, so if you can find your Aurora data set. And now we're going to go over to Mentimeter. So let me just pull that open here. And I want you to go to menti.com and use the code 43409265.
Or the link is in the chat as well, if you'd prefer to just click the link.
Thanks, Beth. Yeah, so let's find your way to that. And then when you're there, what I want you to do is go to Tools, Measure, and I believe I was looking for kilometers, so you'll have to find kilometers as opposed to miles, and measure the diameter of the Aurora. And when you find your answer, love to know what size you believe it's closest to. So I think the options are 300, 600, 6,000, and 12,000, something like that, kilometers. So you might get different answers. And by the way, you probably figured out some of the quirks about working with analysis and measure. You have to go to the geographical location before you open up those tools, because we really only have cursor or ability to move the sphere and draw on the sphere using your finger for both. You can't do them at the same time. So you probably want to find it first and then open the tool. Okay, awesome. And another one that I don't currently have on this program, but that you have on your phone, which I think is a really fun one to study about, and I'll talk about just briefly in a second, but is the Saharan air layer, so the dust plume that blows off of Africa every year. We have a really neat data set for that on your app, and also a tour about it, and that's a fun one to measure as well. Okay. So we're going to do just one more fun interactive example that I think is really meaningful and help you to see the power of the analysis feature. So I'm going to
people ask, What was the answer? You never presented the answer to us.
Oh, let's see. I think at the full width when it comes around, I don't know, probably closer to 6,000, I would say. Yeah. This is not an exact science, obviously, but we can get a sense for how big the pole is, or how big that Arctic region is that gets to see the northern lights firsthand. So it looks like I was getting about 5,000 or 6,000 kilometers there. All right, so there's two ways to, yeah.
I was just going to say, we have one person reporting that their measure tool is grayed out. Is anyone else having that issue, or is it working for everybody?
Analyze definitely gets grayed out often, because we don't have that many data sets that are full data so that we can actually probe them and transect them. But hopefully your measure tool is working properly.
Yeah, if it's not, maybe try exiting the app and fully closing it out and restarting it.
Yeah, agreed. All right, there's two ways to close a data set. One way is to click this X button. Another way is just to load a new data set. So the next thing I wanted to do here under air, we're going to look at a climate model. So this is called the RCP 8.5 climate model that starts in 2006 and goes out to 2100. So hopefully you can see the title there and you can find that as well. So move the sphere around and use as many overlays as you need in order to find, and we should have capital cities back on the app soon. I think that should be coming out very soon. But go ahead and use the country labels and find your favorite city. So kind of zoom in if you can to find your favorite city. And then use this, the window in the upper right. It's a little more challenging to get exactly the year 2070 on the app than it is, of course, on my computer screen, but get somewhere near the year 2070. So you may have to pause and use this timeline scroll bar, or you could even go, 1 year at a time with some of these buttons. And then I want you to probe your favorite city in the year 2070 in the climate model RCP 8.5. So probing is, of course, again, analysis or analyze under the tools button. And it's this first one here with the crosshairs. So I'm just going to probe around my favorite city. And I want you guys to put this into Mendy again. So go to climate model 8.5, RCP 8.5, go to the year 2070. What's your favorite city and what's the temperature change there when you probe it? And I think the key is the temperature change, because that's what we're looking at here. So it's surface temperature compared to the 20th century average. So I would type in, if I had extra screens and such, 7.9 in Barcelona. And add F if you like, that way you know.
And I just want to jump in. If anyone else was having issues with the measure not appearing, our developer, Eric Hackathorn, is answering questions as well. And it had disappeared because of screen settings. So if anyone else is having the issue, check out the chat. The answer is there for you.
Yeah, so just, you know, when you're working with students, you would obviously want to take a moment and clarify what 8.8 Fahrenheit means. Or have them talk about what they believe it means based on what the color bar says. It could be something they could write up in a couple of sentences. Those are fantastic cities. Kids have good taste. Is anybody having any problems with that? Okay. Oh, thank you, Becca, for the survey link. I completely forgot to put that in my slides. So we will worry about that later. But yeah, I have one more. Thank you very much. I have one more question that I'll have you work with on this same topic. So we chose first the RCP 8.5. Let's go to RCP 2.6. So 2.6 as opposed to 8.5. Now these RCP, the relative concentration pathways climate models, are a little bit harder to dig into, but I definitely recommend you doing so. But 2.6, yes, is a lower scenario. So we're looking at, by 2100, a watts per meter squared difference of radiation on the surface of the planet, as opposed to an 8.5. So that's what those numbers mean. So why don't you do the exact same thing, if you can, in climate model temperature change RCP 2.6. Try to find the year 27 best you can, using the animation window there. Probe it, probe your favorite city again, the same city. And then do just a little bit of math in your head. Or not in your head. And type into the chat, what's the difference? What's the difference of the temperature that you get from this more positive future, a more ecologically green future, where we do a lot more carbon mitigation in the future? So by the year 2070, what's the difference in the temperature between the sort of worse aspect or worse scenario versus, it's always hard to find the right words for these, the kind of unhappy scenario in the future versus the happier one. So please chat the difference in the temperature. That's okay. So I believe mine is yeah, so there's lots of ways to mention this. I had a feeling Dallas was a little higher than 1.9. But yeah, this is not an exact science. So this could be a fun jumping off point to talk about climate scenarios and how very much what we do today and what we promote today can affect our lives and our grandkids' lives in 2100. So thank you for participating in that. I think that's mostly what I wanted to go over in the app, and I'm just going to move now to talking about some of the things that we have created for you to help you jump off and use this app. So if you scroll down in your dataset window, you're going to find what we call tours. Now, tours are sort of a story, a scientific story that we have told that guides you through with text boxes, data sets, web pages, videos online, images, all kinds of things to help you learn about something. So this might be a really cool way to have students go take the tour and answer some follow-up questions. So on our website, sos.noaa.gov/education SOSx Tours. So if you're on our webpage, it'll be under education activities, SOSx Tours. It really kind of lays everything out. First, download the app. Second, learn your way around the app by taking a scavenger hunt. We would say this is recommended ages 5 through 10. I would say really it could work just about any age above 5th. We have an all-topic scavenger hunt. We have an earthquakes scavenger hunt. And then we have these tours. So right now we have 2 that are pretty timely that we made this last year. One is called the Saharan air layer. One is about the Saharan air layer called Tour Monster Saharan Dust Plume. And if you have students who have trouble downloading the app, they can watch the tour here on YouTube. And then there are these follow-up questions that have some kind of deeper thought questions associated with them that they can fill out in a PDF, fillable PDF format. So there are 2 of these. One is Her Smoke and the 2020 fire season, which is very pertinent for us here in the West. And then the other one is the SAL tour, or the Monster Saharan. So that's one thing I wanted to point out, are the tours. And then I'm going to go to the slides and just go over some ideas for teaching with SOS Explorer. So there's a number of ways to do this sort of like teaching, right? With technology, there's always a big breadth of opportunity there. So one way that Beth and I use this, because we're informal educators, is that we have canned presentations that we pre-record. I mean, the cool thing is we don't actually prepare much for them. We just kind of get on and use the app So with your phone or your tablet, if you have an asynchronous learning situation, you actually can record yourself on an iPad giving a presentation in the application. So that's totally possible and kind of fun. It could just be like a 5-minute thing that gets people to look at something deeply, or a jumping off point. You can give live presentations like what we're doing here. There are also independent activities like the scavenger hunts and tours. And then I'm going to go to this other page that gives you some ideas for inquiry and literacy, some guiding questions for you, and some other independent activities. So this is our SOSx mobile uses and resources page. And the way to find this one, if you're just coming to our website, is you go to sos.noaa.gov, click on SOS Explorer, and then under mobile, you would go to resources. So there is a lot in here that can help you justify why you would want to bring this into your classroom. Why do we use data visualization education? What skills are being practiced when you're using this? What topics can be covered? How to use it in the classroom more specifically. So you could browse our phenomena-based learning modules, which I'll go over in a second. You could use this list of guiding questions and supplemental materials that were put together by someone at an elementary school for us. You could flip your classroom and just have them use the guided tours and the follow-up activities or the scavenger hunts. There's presentation, lecture, demonstration, group discussion, student-led inquiry, all kinds of different things, from little tiny bite-sized pieces to larger. So we have a few carbon dioxide lessons here. And then below here, we also have these examples of inquiry and scientific literacy, which is basically just putting a data set up, asking them to observe what they see, observe the patterns, what do they notice, and then read the description. Because our descriptions are written typically for people like us who are informal science educators. And so it would be potentially an opportunity to learn new words and things like that. So these are all ideas that I've had, and I think this is a really nice, easy to read page. So the last thing I wanted to talk about with this is also your phenomena-based learning. So if you go to our webpage, Education Phenomena, there's the dog out here, sorry about that. You come to this page. So some teachers really like things that are ready packaged, ready to go, that have like a beginning, middle, and end, and you just use it. Other teachers would rather kind of pick their own adventure, take something and just make their own. So this is more of a take an idea and make it your own. So these are some pretty fun, neat phenomena that you can study within our application. Sorry, if you came in late, I'm actually at a friend's house because my internet's not working today. So I'm in a pop-up camper at their house. So these are all really fun, neat things that were written actually by a pretty young intern for the most part. The tortoise that crossed the ocean. This is a fun one. So when you click into these, you can read briefly about it, have some guiding questions here, and then notice these data sets. For SOSx, use loggerhead sea turtle tracks, use forecast wind streamers, use sea surface currents temperature. So it gives you down here kind of an exact, this is in SOSx or not. Then we have some NGSS standards here, as well as some external resources. So I know we're getting close to the end here, and I just wanted to quickly Also put a plug in. We do know that the how teaching data literacy is still challenging. And please email me if you'd like to be considered for a National Science Foundation study that explores new techniques for teaching with data visualization, especially if you're located in the Northeast. So we're starting recruitment this summer for next summer and summer 2023. I know everybody has been crazed this year, so I'm so glad you're able to take some time and do some professional development. But this would be for next year. Hopefully things are a little more back to normal by then. There is I believe, a survey in the chat, and I wanted to leave you with this, which is, be inspired, go forth, contact us as needed. We would love to help out in your classroom. We'd love to hear what you're doing. If you have things you want to share with us, we are, just really starting our journey with this application. So here are some fun ideas that you might want to use phenomena-based type stuff. So now I am just ready for any questions or ideas that you have. Or Beth, if you wanted to interject at all, if I forgot anything, or Eric, or, oh, maybe Eric can't talk.
I think you got it all, Hilary. Thank you. That was great. We did have one question in case other people missed it. Someone was asking about the availability of these data sets elsewhere. So if you aren't able to get the app for whatever reason, there is a large data catalog on our website. And there's about 550 data sets in there. And there's a little video of each of those data sets, as well as an interactive sphere on the website where you can watch it. So even if it's not available in the app, check our website. There's a ton of visualizations there that you can use. Since we're NOAA, we want you to use our resources. These are all publicly available, so certainly explore the catalog and please use what we have. So Hilary's showing you here a little interactive sphere on the website, and then there's also little .mov files that you can download as well to put into a PowerPoint, for example. So lots of options for getting these great visualizations into your classes.
Gabrielle, you work at AM&H? Cool. Thank you. Yeah, awesome. Let us know how you use it, and we really appreciate you guys showing up. And yeah, you're welcome to leave and be on with your day. Thank you very much.
Yes, thank you for attending all. We appreciate it.